All right. So make sure your notes are out. And this is slide number 11. Make sure, I guess, that you had 10. It was our little recap. This was showing physical weathering caused by plant roots. This was showing chemical weathering caused by oxidation. Based on your results from the Google form, you guys all understand this very well. So we're still looking at how Earth's surface is changed. So obviously, Zach and Aiden, not the shape of the Earth, but just the what it looks like, what we actually see or experience. How can it be affected, right? And so weathering is a big part of that. Whether you're talking chemical or whether you're talking physical, both of those are going to have an impact for sure on what things look like, right? So I said that there were some key words. Weathering is the breakdown. So break it into smaller pieces. Once it's broken into smaller pieces, then it can get washed away or transported easily, which is erosion. And that's what we're going to get into as we get back from break. And then finally, things aren't going to stay moving forever, whether it's being carried by water or by wind. At some point, that speed is going to slow down, and the items that were being carried, whether it's dirt, whether it's sediment, whether it's leaves, whatever it may be, those things are going to be dropped. So deposition is dropped. So weathering, erosion, and deposition, those are our main ideas. So things have to get broken into smaller pieces, then it's easier for them to get moved, and then eventually they will get dropped. So broken into pieces, moved, dropped. So we looked at the broken into pieces. When we see things that are getting broken into pieces, the chemical weathering can maybe soften things or loosen things up, and then it allows those physical agents of weathering to kind of come in and break them apart even more. And that leads us to soil formation. So once rock gets weathered, the smaller sediments might start to form into soil. So in our soil, there are bits and pieces of rock. There obviously are also organic matter, but this is a slow, long process, all right? And so it all starts by things that were big getting smaller and smaller and smaller until eventually they are part of our top layer or our debris, which forms our uppermost layer of the soil. And so the soil is a rock and mineral fragment that is covering the earth, and different locations have different type of soil. You might hear where there's good rich soil, like for farmland. Then there's like clay where there isn't much organic material that's good for growing. It's a lot harder, it can be a lot tackier. Has anybody ever seen red dirt? Like if you've gone maybe out west? No red. Even like in southern Ohio, near like Athens, Ohio, yeah.
I've seen it before.
Yeah, it's really orange, right? It's our ginger dirt, right? And you know I love ginger. So the reason why is the iron that is in that soil. It has been oxidized, so it is basically rusted. I know when we go out to Oklahoma City, the dirt there is always orange, and it's weird because like we have boots that we put on the horses when we run them, and like protective, like they're called splint boots. And usually, like if they get dirt on them here, it's just brown dirt. Well, there when we come home, like all the boots have orange dirt all over them because that's what the sand and the soil is out there. So it's just a difference. It's what they're used to. So I'm sure when they come, like where we have brown soil, you know, they're like, oh wow, all of our boots have brown on them instead of orange. Like it's just a difference. But it all depends on what is making up that soil, right? So what things are there, what have gotten broken down into smaller pieces and eventually formed into that soil. And so high quality soil from plants and animals adds an organic layer. So we know that things don't live forever, and this is true of both plants and animals. So if you have plants that are going through the natural life cycle and they die, well then they're going to lay where they die typically, and then they will start to decay. As that decay process happens, the energy that is in those bonds is not gonna just like go away. And so what happens is it breaks down and it joins up with the, other material that is like right there at the top. And then it forms kind of this organic layer, or what we call the topsoil. And remember, organic just means like once living, okay? And so soil is gonna be a mixture of this weathered rock, the decayed organic material, minerals, water, and air. A lot of times you don't think of there being air in soil, but real good, like peat moss is real airy. And it's really good for growing. It's kind of a special type of topsoil. They will also do something to topsoil called aerate it, where they put it like through a pulverizer and kind of like chop it all up and loosen it. And then it's really good for like flower beds and like planting new yards and things like that. Trying to get it so that it's nice and smooth and easy to put your grass seed or plant your flowers or whatever if they're for flower beds. So air is a component that I think sometimes we don't consider. I think the other parts are all kind of obvious. And this is a very slow process. Yes.
I once caught a snake in the bag of the aerated soil.
Oh, did you really?
Yeah, it bit me, and I threw it in the wall.
No way. Bogus. No.
Nope, it bit me.
It was alive.
Yep.
Mm.
Don't know how it was.
Yikes. Well, I'm glad you're still with us, that it wasn't poisonous.
It was a garter snake. It wasn't poisonous.
Good. Okay, so again, if we don't take care of our soil, then it's not always gonna be good, healthy soil that is good for growing crops, which is part of the reason that farmers pay very close attention to how they rotate crops, how they fertilize, are they doing no-till farming, and we'll talk about that a little bit more. Are they plowing up the fields, like what is their process? And there's, it's not just random, like they have a very set plan to keep that soil good and rich. Because it's not something that we can just snap our fingers and automatically have new good topsoil around, right? So there's some things that are gonna affect the soil formation. Obviously the climate, and we'll get into these in more detail. The slope, so is it flat or is it on hilly ground? The types of rock that are being weathered, right? So in those areas where they have red dirt, it's because they have iron oxide or that rust in their rocks, and then when those rocks weather, they form the soil, and then the soil takes on that red kind of tint like the rocks have. What type of vegetation is around? And that includes considering like the big roots for the trees, or like the cover that certain bushes and things can provide. So there's a lot of factors that the vegetation can influence. And then the amount of time that the rock has been weathering. Is this relatively young in the process of the weathering to form the new soil? Or has this been happening for thousands or maybe even millions of years? Okay, so specifically climate. Remember, climate is like long-term weather. So Ohio has a very volatile, random weather. Like our weather goes up and down. We can be 70 one day and 40 the next. But our climate is still pretty steady, and that's the thing. Climates are not really affected. It's not like you turn on the news and you're gonna watch the climate. You're gonna turn on the news to watch the weather. You also probably don't have a climate app on your phone. It's not really necessary because climates don't really change. You have a weather app so that you can check the daily weather. Yes?
It's gonna be 20 in Mississippi this week.
Yeah, it's gonna get really cold in Florida, Texas. Yeah. We actually are gonna stay a little bit warmer than some of the places that normally stay warmer than us. So climates, if you're talking, okay, so climates are gonna obviously have a huge effect on what is found there. So if you think of like a desert climate, you're gonna have very little organic material. You can see just some shrubs, some woody stumps and things, but nothing really green and lush or a whole lot of vegetation, right? Not a lot of precipitation of any kind either. Now prairies are gonna have thick, dark A horizons because the grasses contribute a lot to organic material. So obviously you can see at some point all of this grass is going to go through its natural life cycle and die. So then when it dies, it is going to start to decay, and then eventually over time, that decayed grass material is going to join up with the current soil and is going to help feed the next generation of these grasslands or prairies. Forests, and we'll talk about the horizons here in a second, those are our layers. But they have a thin A and B layer because of the leaching. So there's, what happens, it's kind of like what we talked about with our acids being able to drip or leach through the soil and dissolve some of the limestone, and that's what formed some of our cave formations. But the same leaching effect happens here where the nutrients are pulled through those top layers because there's so much moisture, and so it's pulling some of that good material that's at the top and pulling it down into the bottom layer. So it kind of thins the top layers because of that. And then the slope of the land. Obviously, the steeper the slope, the harder it is to keep good soil there. Let's face it, gravity, right? It's going to pull things downward. So unless you have really thick vegetation that with lots of roots that can help anchor that soil, you're going to see that soil kind of move downward. So in the valleys, you'll see a lot more good soil, but like looking right here, you can see this hill probably used to be like a lot more flat. You probably didn't plant a tree crooked, right? There probably used to be land there, and because there's not much vegetation right here, there's nothing to protect this soil, and so you have big chunks. And if anybody lives at Candlewood, you probably see this along the banks quite a bit. So a lot of times different places will put big boulders to try to slow this process down. They will try to plant grass to help have roots, and then the roots keep the soil intact. Sometimes they'll even put like retaining walls or other big like concrete kind of structures, like depending on like the area exactly. But if they're really trying to keep that erosion or those big chunks of dirt from being able to just slough off and fall into the body of water, whether it's a river, whether it's a pond. So you can see here like a big chunk has fallen off. I'm assuming big chunk has fallen here. You can see exposed roots. And so on the hill, if there's nothing there to protect the soil, it's going to get eroded away, which means it's going to get washed away or transported to a new location. Now, valleys, on the opposite, are going to be the beneficiaries of that, right? The dirt that falls off the sides is going to be able to land at the bottom, and so typically valleys are going to be nice, rich, lush areas. So this is why settlers, when they came to new areas, typically the mountains could kind of be protection. They could keep an eye on who's coming, and they'd have to come down the mountain. They couldn't just sneak up on them. And they settled in the bottom of these mountain areas and these valleys because they had all this rich soil, and typically water flows downward, and so there's going to be a water supply. So it wasn't just accident that so many villages and then eventually towns and cities grew up in valley type areas. Okay, so soil profiles are pretty easy, and it's not going to be something that like you have to be an expert on. I just want you to hear the terminology, because sometimes we'll call the different layers horizons. All it means is the different layers, and you can visibly see the difference in the soil. So a lot of times we forget that there's stuff deeper than what we can visibly see beyond just like digging a foot into the ground, okay? We put in some of these watering posts and had to dig like 8 feet into the ground over Thanksgiving. Well, my husband did. But you could see like you had the nice topsoil, and then as you get down lower, it kind of got a little bit lighter in color. You saw it get a little bit more rocky, and then the deeper they dug, it got really rocky. It got like where it looked like more rock than it looked like dirt. And you can see that. You know, if you've ever looked inside a really deep hole, like maybe somebody's building a basement, or, you know, adding on somewhere, or just digging a hole for a well or something. Maybe not a well, because you won't be able to see it very good. But if you're digging anything 4, 5, 6 feet deep into the ground, you can definitely see those visible layers or horizons. So A is the top layer, typically gonna be leaves and twigs. This is a good thing to help prevent erosion, right? Because it's gonna keep the soil protected. The wind and water is gonna affect those twigs and leaves, but it's not gonna be able to tear up and take the soil with it as it moves during a storm or some kind of weathering event. And then as these items start to decay, they're gonna put their nutrients back into that top layer. B is a little lighter color and less fertile. And then C is where you have partially weathered rock. It's at the bottom, it's usually the thickest, and it doesn't really contain much organic matter. So you can see kind of here, A, B, and C. There's gonna be different sources will tell you different layers, like they might have an O layer for organic. So you'll hear a couple different things. Don't worry too much about, like I said, I just want you to have the general idea that there are differences in the layers. Soil is not all the same. Okay, so you can see A here. We also call this the topsoil. B, you have a little bit of a mixture. C, you're getting rockier. And then D, or the bedrock, sometimes you'll have even like big slabs. This looks a little bit more like rock than it does dirt as you get down into those points. And so, again, that's just kind of giving you an idea. Don't get too like stressed about, I'm not gonna have you like totally explain every characteristic of every layer.